Okay, this is part of a workshop, rate of change workshop. It's the first video in it. I'm going to just explain where we get started here. Now, one most common rate of change you think about every day is when you're talking about the speed of a car or something, and you go speed equals a distance over time because distance could be kilometers, time could be hours. So kilometers per hour or meters per second. And maybe you remember this triangle here. If you want to find distance, it's speed times time. If you want to find time, it's distance over speed, kilometers per hour. But if you wanted to find speed, you take distance and divide by time. Maybe you remember doing that. But here's two graphs of distance versus time, and it really is important to understand these two graphs here. Now, if you look like this is like a distance, some distance that somebody's got. They're actually stopped. As time goes on, this person stopped here. So if you were talking about the gradient of it is zero, okay? So the speed is zero here. Any horizontal line has a gradient of zero. But here's a straight line going up. Well, whatever this is a gradient that's staying constant. It's a rise over a run. If we measured the rise and put it over the run, the kilometers per hour here, the rate here would be a constant of speed. But here you can see over time it's covering a greater distance for a unit of time. The distance is getting greater. So this is called linear. This is nonlinear. It could be like a parabola, it could be exponential, could be something, but it's not a straight line. And here, the rate of change keeps changing. So in a distance versus time graph, it's pretty important to be able to see these three things. Zero, a gradient of zero, or a rate of change of zero. This is a constant rate of change or a constant speed. And this is a changing rate of speed. Okay. Now, when we do a calculus, when we take the derivative, we're getting a formula that tells us the gradient in just any time at an instant of time. That's what it's for. And you get the gradient of distance versus time. The derivative tells you for any x value, if you have a graph like this, as the x values in time change, you could find the changing rate at any instant of time. Okay, so if you take the derivative again, you get something kind of interesting. It's called acceleration. The rate of change of speed, is called acceleration. Now, the letters they often use in these things are kind of weird. They always use S for distance, so it feels like, why not? They use D, but they use S. They use V of t for velocity and A of t for acceleration. Okay, that's the introduction, and hopefully that helps get some basics together. I hope so.